Hi everyone, my name is Sai Vishnu and I am currently studying at UWTSD. In this short video, I will explain my machine learning project for the module Applications of Machine Learning. I used decision tree and naive Bayes classifiers on two image datasets, Fashion MNIST and CIFAR-10. I will now walk you through the entire code and output step by step. First, I import the required libraries. NumPy is used for handling numerical data, especially image pixel arrays. Matplotlib library and seaborn help us create graphs and heat maps to visualize results. And I use the time module to measure how long each model take to train and predict. And from scikit-learn, I import tools for loading datasets, training models, splitting data, and calculating performance metrics like accuracy, precision, F1 score, and confusion metrics. Then step 2, I download the Fashion MNIST dataset using fetch OpenML. It has grayscale images of clothing like shirts, trousers, and bags. It has I normalize the pixel values from 0 to 220, 255 to a 0 to 1 range, so the model learns better. I also convert labels to integer format for classification, and then I split the dataset into training and testing sets. 80% of the data is used for training the model and 20% is kept aside for testing its accuracy. Then I created a decision tree classifier object and train it using the training data. Then I use it to predict the text labels. I also use the time module to capture how many seconds the model takes to complete training and prediction. Then I train the naive Bayes classifier. Now I do the same naive Bayes using the Gaussian NB model. It trains much faster than the decision tree but may not be accurate for image data. Again, I measure how long it takes using the start and end time. Then for both models, I calculate 4 important evaluation metrics. Accuracy tells us the overall correctness. Precision and F1 score show how well the model performs on each class. I also calculate how long each model took to finish which step, which helps compare speed. And then I printed that decision tree classification report and naive Bayes classification report here, and the confusion matrices helps us to visualize the prediction results in the grid format. Diagonal values show correct predictions while off diagonal values are mistakes. And this is the output. Based on the output, the decision tree model gave 79% accuracy. It performed very well on classes like trouser, sneaker, sandal, and ankle boot. and the confusion matrix shows the strong diagonal lines and the meaning correct predictions. On the other hand, naive Bayes gave 59% only accuracy, but was much faster than decision tree. It struggled to differentiate between shirt pullover and coat, which are visually similar. The final bar chart confirms that the decision tree is better in all metrics except the speed. And now I work with the CIFAR-10 dataset, which contains colored images from 10 categories like airplane, car and all, etc. I import this dataset using TensorFlow Keras library. It automatically loads 50,000 training images and 10,000 test images. And I reshaped and normalized the data. CIFAR-10 images are 32 into 32 pixels with 3 color channels. I flatten each image to 1D, meaning each image becomes a vector of 3072 values. I also normalize the all pixel values between 0 and 1 and flatten the labels. And I use the smaller subset. Since CIFAR-10 is large, I reduce the size to train the models faster. For that, I use only 10,000 images for training and 2000 for testing, which is enough to compare basic models. And then I created and trained the decision tree model using smaller dataset. After training, I use it to predict labels on the 2000 test images. I also track how many seconds it takes to complete. And now I train the naive Bayes model in the same way. This model runs very fast, but as we will see, it struggles to complex data like color images. And here I calculate the performance metrics just like before. I calculate accuracy, precision, F1 score and runtime for both models. Here the zero division equals to 0 parameter prevents error when some labels are missing in the predictions. And I generated confusion matrices. I used scikit-learn to create confusion matrices for both models. These matrices will help us analyze which classes the models are predicting correctly and where they are failing. And I draw heat maps using the same function as before. I draw heat maps for both confusion matrices. This makes it easy to spot strong and weak prediction areas visually. And this is the output. Here decision tree gave accuracy of 24% and F1 score of 0.24. It performs slightly better on classes like truck and ship, but struggled with animals like cat and dog. The confusion matrix shows that many classes were misclassified and most diagonal cells are light, meaning low accuracy. And naive Bayes performed slightly better with an accuracy of 29% and F1 score of 0.27. It predicted a ship and truck relatively better on class ship, and ship had 104 correct and truck had 89, but again it failed on classes like bird and cat. In the final bar chart, we can see that although Naivbase is slightly better in accuracy, both models are not suitable for complex color image classification. For such tasks, we should use convolutional neural networks, which are specially designed for image data. Thank you for watching.